Have you ever wondered how stars are born and die? We're about to embark on a cosmic journey beginning with the birth of a star. Stars aren't simply born, they're formed, sculpted by the hands of the cosmos from vast celestial clouds of dust and gas known as nebulae. These nebulae don't just sit quietly in space, they're stirred into activity by the forces of the universe, setting the stage for the birth of a star. As gravity pulls the dust and gas together, a process known as gravitational contraction, the core of the nebula begins to heat up, giving rise to what we call a protostar. This protostar is the first step in the journey of a star's life. With its high temperature and pressure, it's a stellar seed ready to grow into a full-fledged star. So that's how a star is born, but how does it evolve? Let's find out. Once a star is born, it enters a stage called the main sequence. But what is this stage all about? The main sequence is where a star truly comes alive, spending the majority of its lifetime. This stage is all about balance. In the heart of the star, a constant tug of war takes place. The inward pull of gravity versus the outward push of pressure from nuclear reactions. Here, under extreme temperatures and pressures, the star's core is a nuclear furnace, burning hydrogen into helium. This process, known as nuclear fusion, releases enormous amounts of energy in the form of light and heat. It's this light that makes the star shine brightly in the night sky, and this heat that keeps planets warm. This balancing act continues for millions, even billions of years depending on the size of the star. The star remains stable, constantly emitting light and heat, but nothing lasts forever. After millions or even billions of years, the star exhausts its hydrogen supply and its life takes a dramatic turn. What happens when a star runs out of hydrogen? It expands into a red giant. This is the next stage in the life of our celestial protagonist. Picture a balloon, slowly filling with air. Like a balloon, a star expands as its core heats up, burning helium into heavier elements. The star, once a concentrated sphere of power, now balloons out, its outer layers stretching and cooling until the star resembles a glowing crimson orb, a red giant. But the transformation doesn't stop there. The core of the star continues to heat up, ever hotter, ever denser, fusing helium into carbon, and carbon into even heavier elements. The energy generated by these reactions pushes against the force of gravity, causing the star to expand even more. The outer layers of the star become so diffuse, so loosely held by the star's gravity, that they begin to drift away, creating a nebula, a cosmic cloud of dust and gas. This is the red giant stage, a phase of celestial metamorphosis where the star, once a beacon of light and heat, becomes a diffuse glowing cloud, a nebula. But this is not the end. Far from it. The core, stripped of its outer layers, continues to collapse under its own gravity. The pressure and temperature rise until they reach a critical point, triggering one of the most spectacular events in the universe, a supernova. A supernova is a titanic explosion, a cosmic firework display that can outshine an entire galaxy. The star, once a bright point of light, now illuminates the cosmos with its death throes. The energy released in a supernova is so immense it can be seen from billions of light years away. But this dazzling spectacle is more than just a fireworks show. It's a cosmic forge, where elements heavier than iron are created. It's in these final violent moments of a star's life that the building blocks of the universe are formed. The supernova is the dramatic end of a star's life cycle, but it's not the final stage. The remnants of the star's core, still collapsing under their own gravity, have yet another transformation to undergo. But that's a story for another time. After a supernova explosion, what's left of the star becomes a neutron star or a black hole. But what are these exactly? A neutron star, as the name suggests, is made almost entirely of neutrons. It's the collapsed core of a massive star, and despite being only about 20 kilometers in diameter, it's incredibly dense. Picture a sugar cube weighing as much as a mountain. That's the kind of density we're talking about. These stars spin at a mind-boggling speed, sometimes hundreds of times per second. On the other hand, black holes are points in space where gravity is so strong that nothing, not even light, can escape. The star's mass is compressed into an infinitely small space, known as a singularity. Around this singularity, a region forms where escape becomes impossible. This is the event horizon. And there you have it. The life cycle of a star, from its birth in a nebula to its death as a supernova and beyond.